Good day, viewers. Welcome to my YouTube channel, Master David and Victor Adewale Adeleke. Okay, without wasting much time, let's quickly see what would be the derivative of the inverse cosec x. Very, very simple. It's not difficult at all. Now, what do we do? Just rewrite this equation in another fashion. So, if you are doing that, this becomes the cosec y equals to x. Why becoming like this? Now, if you notice, know that if you want to find the value of y from this equation, you have to make y subject formula, right? That is a normal algebraic process. So if you are doing that, you are moving this cosec, this trigonometrical function, the cosecant function to this other direction. And if you are doing that, it becomes an inverse function of x. So cosecant inverse, so inverse cosecant x. So y becomes equals to what? To inverse cosecant x. That is the same as we had here. So, but we only rewrote the question in another word, in another fashion. So from here we can continue. From here, you can now do what? To differentiate implicitly. And if you are doing that, differentiating this implicitly, check on my video if you are not familiar or you don't know how to differentiate cosecant value for x. Go and look for how to find the derivative of that. I've already explained that in one of my videos. Check on this video or this channel, check on it, and you will see a video that I created specifically for what? For finding the derivative of cosecant. Now, once you are done with that video, come back here and you're going to understand what I'm going to do here. So if you find the derivative of the cosecant of x or y, since we are looking for y here, if you find the derivative of the cosecant y, you are going to get the negative cotangent y and what? And the cosecant y. This is what you are going to get. So don't forget you are differentiating both sides. See, because whatever happens to the right hand side happens to the left hand side. So since you have differentiated cosecant y, you have to differentiate what? Cosec. You have to differentiate x. And if you are doing that, you are going to get dx dy. Now this is in a form of an inverse form of what we're actually looking for, because in calculus we are looking for the gradient, and gradient is what changing y with respect to changing x. So what do? We have to return this to what? To the gradient fashion. So if you are doing that, you switch this over and you're going to get dy all over what? Over dx. Now since you've done that, everything here will also be switched over and you're going to get 1 all divided by what? All divided by the cotangent y and the what? And the cosecant y. Now from here, many persons will get stuck because they don't know what to do from ends. But now remember this Pythagorean identity. If you are not familiar with this first Pythagorean identity here, do not be confused, do not be dismayed. It is very simple. Check on the link in my comment section. I will drop a link on the comment section. Check on it. You will see I posted a video. I tagged it proof of Pythagorean identities. If you check on that video, I explained how this was derived from a right angle triangle, Pythagoras popular or his shape that he enjoys so much. Check on that video, you understand all what or how this identity came about. Now from this identity, it was, you can see what I did. It was an algebraic process that was moved, making cot or cotangent y subject formula, and we had cosecant squared y subtracting 1 from it, all square rooted. So that's what we're going to do here now. So we're going to substitute the value of cotangent y now, which we've made subject formula from the identity that we have already known. Doing that, we're going to get dy dx is equals to -1. Now what is cotangent y? Cotangent y is now what? Is, okay, let's try to be as clean as we can. Okay, we have cosecant y, cosecant squared y, I'm subtracting 1 from it. Then we have with what? The cosecant at the side. So I think I should, this is dots here, so let me put the dots here. So we have the cosecant y. Yes, but don't forget, what is cosecant y? Cosecant y is equals to what? To x. So instead of writing it in terms of cosecant, in terms of cosecant, you can write it in terms of what? In terms of x. Instead of writing it in terms of cosecant y, write it in terms of what? Of x. We are going to get the -1. So this is going to become the -1. This x, this is x, so we write it there, x. Then we have x squared minus 1. So you see that now we have a negative. So this is the solution. We have the -1 all divided by x, then square root of x squared minus 1. So that is the derivative for what? The inverse cosec x. So what about the derivative for inverse sec? The derivative of inverse what? Of inverse sec x. Yes. Now the same thing applies here. This can also be rewritten to become sec y equals to what? Equals to x. Now what is the what? the derivative of sec y or sec x. Yes, if you differentiate this, you are going to get what? You are going to get tan x sec x. Yes, if you differentiate sec or secant, yes, if you differentiate secant, you're going to get if you differentiate sec y, you're going to get tan. Sorry, this is going to be y. Yes, y. Yes, check on my video also that I made a special video on that. Check on it and understand what I did here. So because you are differentiating, you're going to get what? Dx dy. Making Solo's formula there, you have the y dx would be equals to what? 1 all divided by what? By tan y, then sec what? Sec y. Now remember that 1 plus tan square x, or okay, let me use y, must be equals to secant square y. Yeah, this is also another Trig identity. Check on that video and understand what I'm doing here. Now from here, what do we do? Making Solo's formula of the tan y. Yes, of tan. If you make Solo's formula of tan, you are going to get this. Let me quickly write. So dy dx. So yeah, so making Solo's formula of tan from here, you are going to get tan will be equals to, that's representing everything here. Since here we have tan, just represent it with what? With what you have made Solo's formula of tan here. So you are going to get what? The square root. Let me write it here. Don't forget we are going to have a secant y here. Yes, I'm trying to minimize space. So here we are going to get what? Secant square y minus 1. That is the square root of what? Of tan. Also, or the subject formula of what? Of tan y. So this is what we are going to get. Now remember that secant y is equals to x. So from here, you just say that dy dx will be equals to what? Your 1, positive 1, all divided by what? X all square rooted, x producing all square root of what? Of x square minus 1. So you can see it's in similitude to what? To the inverse cosecant, the trig of the inverse cosecant, or just the negative sign difference. So that's just it. If you are yet to subscribe to this channel, do it to subscribe, like, and share this video. Stay tuned.